Hello, and this is a continuation of the previous tutorial. We will be discussing about characteristics of period, and here we will be discussing about nature of oxides. Now, in a period, when we move from left to right, the basic nature of oxides, that means basicity, like alkalinity or opposite of acidity, basic nature of oxides decreases. That means as we move from left to right, the oxides become lesser and lesser basic, and acidic nature of oxides decreases. Okay, and we will explain how it is. Look at period 3. Start with sodium and end with chlorine. Of course, I did not include argon for the reason which I have explained before. Sodium oxide is highly basic. Sodium oxide is highly basic. It reacts with water to form sodium hydroxide, which is highly alkaline in nature, very slippery, very alkaline in nature. Magnesium oxide, it reacts with water, not as fast, as vigorously as sodium oxide, forms magnesium hydroxide, which is not as alkaline as sodium hydroxide. So definitely it is lesser basic. Aluminium and silicon, they are amphoteric. So now we can see a bridge here. Amphoteric means aluminum silicon oxides are amphoteric, means they exhibit both acidic and basic characteristics. For example, amphoteric oxides display both acidic and basic characters. Take an example, for example, aluminum oxide Al2O3. Aluminum oxide reacts with hydrochloric acid HCl to form aluminum chloride and water. Here it is reacting with hydrochloric acid, that means it is showing a basic property, basic characteristics, because it is reacting with acid to form salt and water. Definitely it is acting like a base. A base reacts with acid to form salt and water by definition. So in this reaction it is acting as a basic oxide. Now take another example. Aluminum oxide reacts with sodium hydroxide to form sodium aluminate. It is another salt. But look, here it is reacting with alkali to form a salt. So that means it is behaving like an acidic oxide here. So it is an amphoteric oxide. Aluminum oxide is an amphoteric oxide which exhibit property both like acid and like base. Okay, now let us move out of amphoteric oxide and come to phosphorus, sulfur and chlorine. Phosphorus form two kinds of oxides, phosphorus trioxide P2O3 and phosphorus pentoxide P2O5. This phosphorus, sulfur and chlorine, all three oxides are acidic in nature, but their acidity increases when you move from phosphorus to sulfur to chlorine. So phosphorus trioxide and phosphorus pentoxide forms acid with water, hypophosphoric acid and phosphoric acid. Sulfur dioxide and sulfur trioxide also forms acid with water, sulfurous acid and sulfuric acid. Sulfuric acid is quite very strong acid, of course. Chlorine reacts with oxygen to form Cl2O and Cl2O7, which reacts with water to form very strong acid. So as we move from phosphorus to sulfur to chlorine, their oxides becomes more and more acidic in nature. That means it becomes more and more acidic. So Cl2O, Cl2O7 is more acidic oxide than SO2, SO3, and they are more acidic oxide than phosphorus trioxide P2O3 and phosphorus pentoxide P2O5. So basic nature of oxides decreases as we move from left to right in the period. Acidic nature of oxides increases as we move from left to right. So basic nature decreases, acidic nature of oxides increases. So this is about nature of oxides along a period. Next we will discuss about groups.